Hello students, welcome to chemistry class. Hope you all have performed your FA1 very well. Today, let us learn the lesson Structure of the Atom. In the last lesson, you have learned Dalton's atomic theory. You have learned many postulates of Dalton's atomic theory. In one of the postulates, you have learned that atoms are indivisible. What is meant by indivisible? Atom cannot be divided further. But the discovery of two fundamental particles, electrons and protons, inside the atom led to the failure of these aspects of Dalton's atomic theory. J.J. Thompson was the first one to propose a model for the structure of an atom. Let us see Thompson's model of an atom. Thomson proposed the model of an atom to be similar to that of a Christmas pudding. The electrons in a sphere of positive charge were like currants means dry fruits, in a spherical Christmas pudding. Here you can see these electrons are similar to the dry fruits. The pudding is similar to the positive sphere. That means electrons are embedded in a positive sphere. It can also be compared to a watermelon. The positive charge in the atom is spread all over like the red edible part of the watermelon, while the electrons are studded in the positively charged sphere like the seeds in the watermelon. That means here these electrons are similar to the seeds in the watermelon and the positive sphere is similar to the red edible part. From these two comparisons, he proposed that an atom consists of a positively charged sphere and the electrons are embedded in it. The negative and positive charges are equal in magnitude. So, the atom as a whole is electrically neutral. So, here you can see atom consists of a positively charged sphere in which the electrons are embedded or studded in this. And the total magnitude of the total positive charge is equal to the magnitude of total negative charge. That's the reason atom is electrically neutral. Now let us see what is a drawback. What is meant by drawback, disadvantage or limitation of Thomson's atomic model. Although Thomson's model explained that atoms are electrically neutral, the results of experiments carried out by other scientists could not be explained by this model. That means later many scientists found out the different models. So what they found out, this Thomson's model could not explain.
In this module, you will learn about Thomson's atomic model. Are the charged particles arranged in any particular manner? Are the charged particles spread throughout the atom, or are they concentrated in one place? To answer these questions, let's go back in time. Dalton's atomic theory stated that an atom was indivisible and indestructible. However, in 1886, Goldstein came upon positively charged radiations in a gas discharge, which he termed as canal rays. These radiations led to the discovery of the proton. The mass of a proton was about 2000 times that of an electron, and it carried a positive charge. Around the year 1900, J.J. Thomson conducted experiments on the beams of particles inside a glass tube called a cathode ray tube. He found that the particles were attracted to the positive terminal of the tube. Thomson concluded that the particles must be negatively charged and called these particles electrons. An electron has a negligible mass and has a charge of -1. These discoveries made the scientists believe that an atom was divisible and made up of electrons and protons. What they didn't know at the time was how these electrons and protons were arranged within an atom. They tried to understand this arrangement through various experiments. J.J. Thomson was the first to put forward a model to explain the structure of an atom. In his model, Thomson compared an atom to a Christmas pudding. The electrons were like the raisins in the pudding, and the pudding itself was like the positively charged particles. This can also be explained through the example of a watermelon. The positive charge in the atom is spread all over like the red, fleshy part of the watermelon, while the electrons are embedded into the atoms like the seeds of the watermelon. The oppositely charged particles are held together by electrical force of attraction. Thomson concluded that an atom consists of a positively charged sphere with electrons set within the sphere. An atom is electrically neutral as the positive and negative charges within it are equal. As per Thomson's conclusion, the electrons were embedded in a sphere of positive charge. This conclusion, however, was incorrect. Thomson asserted that the positive charge spread through the atom held the negatively charged electrons due to electrical forces. This assertion failed to explain many experimental observations. In this module, you have learnt that atoms are made of charged particles. According to Thompson's model, an atom is a positively charged sphere with electrons set within it. An atom is electrically neutral. Shortcomings of Thompson's model are his incorrect assumptions. Electrons are embedded in positive charge. Positive charge in the atom holds the negatively charged electrons.
Next we learn Rutherfords Model of an atom. Ernest Rutherford designed an experiment to know how the electrons are arranged within an atom. So Thomson couldn't explain how these electrons are and positive charges arranged properly. In Rutherford's experiment, fast-moving alpha particles were made to fall on a thin gold foil. So what is an alpha particle? An alpha particle is a doubly charged helium nucleus. That means a helium nucleus. It is having two positive charge. So when this helium alpha particles are made to fall on a gold foil, and he arranged one fluorescent screen also here to know that means if these alpha particles are hitting on the screen, a glow will be formed there. So from that we can find out which direction these alpha particles are moving. So here you can see a few are moving in a straight line without any deflection. A few are deflecting from their path. Deflection means what? Change in from the path. Change in the direction. So very few of them deflected at large angles and very few, a small fraction, bounced back. So from this experiment, what are the observations he made? What did he observe? Let us see. Most of the fast moving alpha particles pass through the gold foil. Here we can see most of the particle without any deflection, they are passing in a straight line, we can see here. Now let us see what did he observe from this experiment. Observation made by Rutherford. Most of the fast moving alpha particles pass through the Gauss foil. Here you can see most of the alpha particles without any deflection. They are passing in a straight line. Some of the alpha particles were deflected by the foil by small angles. Here you can see some of them deflected. That means changed its path in small angles. 1 out of every 12,000 particles appear to rebound. Rebound means bouncing back. So out of 12, very small fractions were rebounding or bouncing back. Out of this calculation is given to understand very small fraction. That means out of 12,000 only one particle. Such a small fraction of particles were bouncing back. So from this observation, what he concluded, let us see. What are the conclusion of Rutherford alpha ray scattering experiment? Most of the space inside the atom is empty because most of the alpha particles pass through the Gauss foil without getting deflected. So we have seen already most of the particles are passing without any deflection. What does it mean? That nothing is hindering them. So there is no hindrance, so easily they can pass. That means most of the space in the atom is empty. Next, very few particles were deflected from their path, indicating that the positive charge of the atom occupies very little space. So most of them are passing without any deflection and very few are deflected. What is the meaning of that? So, you know, alpha particle is having positive charge. So positive and positive repels. So here due to the repulsion only these alpha particles are deflecting, changing their path instead of going straight. So very few deflected. What does it mean? The positive charge occupies very small space, a very little space. Next, a very small fraction of alpha particles were deflected by 180 degree, indicating that all the positive charge and mass of the gold atoms were concentrated in a very small volume within the atom. So here very small fraction were bouncing deflected by 180 degree. Deflected by 180 degree means what? Here the incident path and reflected path are the same. That means 180 degree bouncing back. So very small fraction of the alpha particle were deflecting or bouncing back. What does it mean? All the positive charge and mass of the atom are concentrated in the center of the atom, that is called the nucleus. So we have seen the observation. From the observation he concluded. What was his conclusions? Most of the space inside the atom is empty. That's the reason most of the alpha particles were passing through without any deflection. Then we have seen very few particles were deflecting. From that what we can understand? The positive charge of the atom occupies very little space. Then very small fractions were bouncing back. What does it mean? All the positive charge and mass of the atom are concentrated in a very small volume within the atom. So from this observation, let us see what are the features of this Rutherford's nuclear model. There is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. The electrons revolve around the nucleus in circular paths. That means almost all the positive charge and mass of the atom is at the center in a small region called the nucleus, and electrons are revolving around the nucleus in circular paths. So we have seen now how did he conduct the experiment, what did he observe from his experiment, and from the observation what did he conclude, and what are the features of nuclear model of Rutherford. So what are the features? there is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. Then the electrons revolve around the nucleus in circular paths. The size of the nucleus is very small as compared to the size of the atom. So, comparing the whole size of the atom, the nucleus size is very small. Now, let us see what is the drawback of Rutherfords model. So, according to physics, there is a fact that any particle which undergo acceleration, any particle in a circular orbit would undergo acceleration. You have learned in physics what is acceleration. What is acceleration? Change in velocity. That means it can be a change in magnitude or it can be a change in direction. So you are also learned that the circular motion is a type of accelerated motion. What is the reason? In circular motion, each moment the direction changes. So take a particular point here. Instead of going straight, it is changing its direction, it is turning. Here, instead of going straight, it is turning. That means each moment it is changing the direction. That is the reason we can consider circular motion as an accelerated motion. So any particle in a circular orbit would undergo acceleration. And one more fact is there. During acceleration, charged particle would radiate energy. That means if any charged particle undergo acceleration, it would radiate energy. That means it releases energy or losing the energy. Thus, the revolving electron would lose energy and finally fall into the nucleus. You know already the electrons are negatively charged particles. So, any charged particle undergo acceleration. As it is moving in a circular path, it undergo acceleration. So, any charged particle, when it undergo acceleration, loses energy. So, this electron, when it is revolving around the nucleus, it loses energy, going on losing energy, and it comes nearer and nearer to the nucleus. At last, it falls to the nucleus and atom collapses. That means it destroys. But actually, already you have learned atom cannot be destroyed. Atoms are stable. So, Rutherford could not explain the stability of the atom, why the atom is stable. According to him, the atom should destroy. So, any particle in a circular orbit would undergo acceleration. During acceleration, charged particles would radiate energy. Thus, the revolving electron would lose energy and finally fall into the nucleus. If this were so, the atom should be highly unstable and hence matter would not exist in the form that we know. We know that atoms are quite stable. So, Rutherford's model could not explain the stability of the atom.
Rutherford's model of atom. The quest for discovery led the British physicist J.J. Thompson to discover electron. Further, he proposed an atom model which laid the foundation for advancement of research in the atom model. Significant research work on the atom model was done by British physicist and chemist Ernst Rutherford. Ernst Rutherford was interested in knowing how the electrons are arranged within an atom. As such, in 1909, he conducted an experiment where he bombarded gold foil with alpha particles or helium nuclei called as alpha particle scattering experiment. In the experiment, a radioactive source of alpha particles was placed in a lead box containing a small hole. The alpha particle which hit the inside of the box was simply stopped by the box. Only those alpha particles which passed through the opening were allowed to escape, and they were confined to a straight line. They passed through the lead sheet with a small slit. They bombarded the extremely thin gold foil. The alpha particles which were scattered were detected using a detector and a circular fluorescent screen which was coated with zinc sulfide. As such, Rutherford observed that most of the alpha particles passed straight through the foil, implied that most of the space inside the atom is empty. Some alpha particles were deflected by the foil at small angles, indicating the Rutherfords model of atom. The quest for discovery led the British physicist J. Thompson to discover electron. Further, he proposed an atom model, which laid the foundation for advancement of research in the atom model. Significant research work on the atom model was done by British physicist and chemist Ernst Rutherford. Ernst Rutherford was interested in knowing how the electrons are arranged within an atom. As such, in 1909, he conducted an experiment where he bombarded gold foil with alpha particles or helium nuclei, called as alpha particle scattering experiment. In the experiment, a radioactive source of alpha particles was placed in a lead box containing a small hole. The alpha particle which hit the inside of the box was simply stopped by the box. Only those alpha particles which passed through the opening were allowed to escape, and they were confined to a straight line. They passed through the lead sheet with a small slit. They bombarded the extremely thin gold foil. The alpha particles which were scattered were detected using a detector and a circular fluorescent screen which was coated with zinc sulfide. As such, Rutherford observed that most of the alpha particles passed straight through the foil, implied that most of the space inside the atom is empty. Some alpha particles were deflected by the foil at small angles, indicating the interactions with other positively charged region within the nucleus. Very few alpha particles bounced back to the source, indicating that all the positive charge was concentrated within a small volume within the atom. Based on these observations, Rutherford put forward the nuclear model of an atom, which has the following features. There exists a positively charged center in an atom called nucleus, and nearly all the mass of an atom is concentrated in the nucleus. Electrons revolve around the nucleus in well-defined orbits. The size of the nucleus is very small as compared to the size of the atom. Things to remember. In 1909, Ernest Rutherford conducted an experiment called the alpha particle scattering experiment. The passage of alpha particles through the gold foil is observed for analysis. Positively charged center in an atom is called nucleus. All the mass of an atom is concentrated in the nucleus. Electrons revolve around the nucleus in well-defined orbits. The size of the nucleus is very small as compared to the size of the atom.
Next, let us learn Bose model of the atom. In order to overcome the objections raised against Rutherford's model of the atom, Niels Bohr put forward the following postulates. Let us see what are his postulates. Only certain special orbits known as discrete orbits of electrons are allowed inside the atom. Here you can see, already we have seen, the center of the atom is called nucleus. All the positive charge is concentrated at the center and the electrons are revolving around the nucleus. So the electrons cannot revolve as they like in any path. There are some discrete units, discrete orbits or separate orbits. So only certain special orbits known as discrete orbits of electrons are allowed inside the atom. While revolving in discrete orbits, the electrons do not radiate energy. We have seen in Rutherford's model, he could not explain the stability. Why? Because any charged particle, when it is revolving around the nucleus, would lose energy and finally it comes to the nucleus and collapses. The atom collapses. But here Bohr suggested that when these are revolving, the electrons are revolving in discrete units. As long as they are revolving the same orbit, they do not radiate energy. So, when electron is moving in the same orbit, it cannot radiate the energy. So, he could explain the stability of the atom. These orbits or shells are called energy levels. These orbits or shells are represented by the letters K, L, M, N or the numbers 1, 2, 3, 4, etc. Here you can see this is the nucleus and these are the orbits. First shell or orbit or energy level, it is called K shell. Second one L shell. Third M shell. Fourth N shell and so on.
Bohr's model of an atom. In this module, you will learn about the Bohr's model of an atom. Prior to Bohr, there were a number of scientists who were working on the structure of atom. Rutherford was one of them, and his model was the closest model to the Bohr model of atom. In fact, Niels Bohr had helped to overcome the problem in the Rutherfords model of an atom. The Rutherfords model of an atom had a major drawback, that it could not explain the stability. It showed that electrons in an atom revolve around a positively charged center called nucleus. However, later on, it was found that any particle in a circular motion would undergo acceleration and thus would lose energy. So, the electron would take a spiral path and would finally fall into the nucleus and the atom would collapse. But this does not take place in reality. Bohr said that electrons do revolve around the nucleus, but their energy remains fixed. He explained that the energy of electrons remains fixed because they are restricted to some fixed orbits. Each of these orbits is at a fixed distance from the nucleus and is associated with a fixed amount of energy. These orbits with fixed energy are known as discrete orbits or energy levels. These energy levels are represented by the letters K, L, M, N or the numbers 1, 2, 3, 4 starting from the center. So, the final model of Niels Bohr was similar to the Rutherford's model of an atom, which states that an atom consists of a positively charged center around which the electrons revolve. The only difference was that in the Bohr model, electrons revolve around a nucleus in fixed orbits with fixed energy. For his work on structure of atom, he got a Nobel Prize in 1922. Let's recap. Bohr model of atom suggested that an atom consists of a positively charged nucleus and electrons revolve around it in special orbits called discrete orbits or energy levels. The energy of these discrete orbits remains fixed. These energy levels are represented by 1, 2, 3, 4 or KLMN starting from the center. Bohr got the Nobel Prize for his work in 1922.
So let us revise what we learned in this lesson. First we learned Thompson's model of an atom. According to this model, an atom consists of a positively charged sphere and the electrons are embedded in it. The negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. Then we learned the drawback of this model. That means later what the scientists found out could not be explained by this Thompson's model. Next we learned Rutherford's model of the atom. To understand this structure of the atom, Rutherford conducted one alpha ray scattering experiment. Then we learned what he observed from this experiment, what are the conclusions he made, and what are the features of his model. The features of his model are: there is a positively charged center in an atom called nucleus. Nearly all the mass of an atom resides in the nucleus. The electrons revolve around the nucleus in circular paths. The size of the nucleus is very small as compared to the size of the atom. But what is the drawback of Rutherford's model? He could not explain the stability of the atom. Then we learn Bose model of an atom. According to Bose model, only certain special orbits known as discrete orbits of electrons are allowed inside the atom. While revolving in discrete orbits, the electrons do not radiate energy. Hope you understood today's class. Thank you.